This is Unit 2, Lesson 3, Topographic Maps, Part 3, Interpreting Topographic Maps. So we're going to really be looking at contour maps in a lot more detail. We're going to look at how do we know what something looks like, and the contour lines are going to become very important. Reading them is going to become important in this lesson. Our learning target for today is I can determine the contour interval and steepest areas on a map, and I can interpret topographic maps and determine direction of stream flow and landscape features. Our success criteria is very similar. I can use the labeled elevations of a map to determine the contour interval and analyze the closeness of contour lines to determine the steepness of a slope. I can determine the direction a stream is flowing by analyzing the way contour lines bend around a stream. First thing we're going to need to talk about is something called contour interval. The contour interval is the elevation change between the contour lines. So it's the change in elevation. It is always a simple multiple. The multiples I have seen most frequently are 10, 20, 25, 100, maybe 1,000. But in general, these are the numbers you could expect to see. So if we're looking at this particular map, and this is obviously just a very simplified landscape, we want to know the contour interval of this map. We're looking for the elevation change between them. So if I have 0 meters here, which remember is sea level, and then 100 meters next, the change in elevation from 0 to 100 is 100 meters. Between this line and the next, from 100 to 200, the change in elevation is again 100 meters. So the contour interval for this map is 100 meters. And that's as simple as it is. Sometimes you'll be given contour interval on the map, sometimes you won't. If you're not given it, you will need to figure it out by looking at labeled elevations and subtracting. So let's do another example. Here's another map. What's the contour interval here? So I have 2 points, X and Y. I have 2 labeled elevations. So this is an elevation of 300. This is 400. And we need to figure out what each of these lines is going up by. So there's 5 spaces in between here. The difference between these two numbers is 100. So 100 divided by 5 is 20. So that means each of these lines is going up by 20. You can do that. You can also just figure out, okay, if this is 300, this is 400, what does this have to go up by? I know it's not 100, obviously. We could try 10, 310, 320, nope. 320, 340, 360, up 380 is the elevation, so the contour interval is 20. So there are different ways to figure this out. It's really whatever works best for you. The next thing we want to do is interpret the steepness or the gradient of the slopes. So the word gradient is the change in elevation over a distance. So how much is it going up or down in a certain space or a certain distance? When you have closely spaced contour lines, that indicates a relatively steep slope. So if you look here, these contour lines are closer together. And this is a side view of this same map. So you can see here, it's much steeper. It's like if you were going up a big hill, the lines would be very close together. Lines that are widely spaced apart indicate a gentle slope, meaning that is flatter. So the elevation is changing very slowly. Again, these two maps are the same thing. So here are the contour lines. They're spaced out a lot more. We call this a gentle gradient. Here is the side view of this map. This is if you were looking at it from the side rather than looking at it from above. And this is a much gentler slope or gradient than this side. So now that we kind of understand how to figure out if something is steep or not steep, we can look at different landforms on topographic maps. The first kind of landform I want to look at are hills or mountains. And I'm only going to go over the ones that come up the most frequently. I just want you to recognize what a hill looks like. So you have one closed contour line surrounding another. So you have concentric circles right here, here. The elevation is increasing. This is what a hill or a mountain would look like. So you have the lowest elevation here on the outside, and then as you go towards the middle, you have the highest elevation. So this would be like a big hill. If you want to look at a real world example, okay, so here's McKee again. You go up Fort Hill Place, and you get to the top of Fort Hill Place. Here's this last closed circle, and then you would start to go back down. So there's a lot of hills in this area. Okay, the last thing I want to talk about is rivers and streams and how we can kind of interpret those on a map. So we have a kind of stylized or drawing of a stream here. So when a river or stream crosses a contour line, the contour line bends and points upstream. So here's the contour line that they're bending upstream. Upstream is where the river starts, which is always at a higher elevation. Downstream is where the river ends, which is always at a lower elevation. Remember, things have to go downhill. Gravity makes things go downhill. So you can either look at the way that this is bending around the stream. You know, this is upstream, so this is the opposite direction. Or you can just look at where elevation is decreasing. It's getting lower this way. So the stream is definitely going in this direction, and we would like to name this direction. This direction is southeast. So let's look at one more example. So this is from a real topographic map, and here is a stream. And notice that these contour lines are bending upstream. They're bending towards the east, which means they're flowing downstream, which is this way. So this particular stream is running west. So that was it for this part of the lesson. So we wanted to be able to determine a contour interval in steepest areas and interpret topographic maps and determine the direction of stream flow and landscape features. And that's it for this video.